Okay, these are some review problems from an old exam. So I thought I'd quickly go over the solutions to these problems. The first one, you're given this circuit. The node voltage V1 is given to be 20 volts. And I mentioned in class that if you know the node voltage of voltages of a circuit, in general, the circuit's pretty easy to solve from there. Okay, so that's what we know in this case. We know that V1 is 20 volts. So that'd be between this point right here, plus, and the reference point down here, minus. Okay, and so from there, if this is 20 volts, there's no resistor along this path. If I slide the dot like we talked about in class, 10 volts here. On the other side, this would be 20 minus 10, which is 10 volts. So we have 10 volts here, okay? And so if that's 10 volts, you slide the dot between here and here, that's 0, that's 10. So this would be 10 volts across the resistor. So the current is going to be 10 divided by 10, which is 1 amp. Okay? So if you're looking for the power associated with the 10 ohm resistor, then that would be V times I. We know V is 10, and we know I is 1, and so this would be 10 watts. And that's using power. That makes sense, it's a resistor. Okay, next we want to look at the 5 amp source, and we want to know the power associated with the 5 amp source. Okay, so what I need to know is the voltage across the 5 amp source, and of course I know the current through it is 5 amps. Alright, so power is V times I, and if I slide this dot back, I know that the plus terminal is here, that's 20, and the minus, slide that dot, there's minus, so it's 20 volts across the source. What sign convention is this? The current's coming in the direction of a voltage rise. Okay, so it's the active sign convention. So this would be 20 times 5, which is 100 watts. And because it's the active sign convention, it's supplying power. So you see that problem, like I said, if you know the node voltages, it's pretty easy to solve the rest of the problem. Okay, moving on to problem number 2. On problem number 2, I'm asking for equivalent resistance. So I'm looking and I notice these look like they would be in parallel. So 48 in parallel with 16, turns out that's 12. You can do that calculation and check it. So here's 12. And so from there, I have the 312 in series with 12. Okay, so I know that that part in the green, the equivalent resistance, is 324. Okay, from there, you have plus and minus. The voltage across the 324 is the same as the voltage across the 108, which puts the 324 in parallel with the 108. And so 324 in parallel with 108, that turns out to be 81 ohms. Okay, and so what we have left is 19 ohms, 81 ohms. These are in series, so 19 plus 81, that gives you 100 ohms for the resistance between points A and B. Okay. The third problem, I still expect you to be able to solve linear systems of equations. You can work on that one. I think the answers turn out to be 7 and 11. Okay, so that's the first half. I'll make another video covering the second half of these problems.